There we go. So, we need to recognize here in number 13. I know it's been a hot minute, so I'm going to read through it. High school students from track teams in the state participate in a training program to improve their running times. Before the training, the mean running time for the students to run a mile was that long with a standard deviation. After completing the program, the mean running time for the students to run a mile was 368 seconds with a standard deviation of 30 seconds. X represents the running time for randomly selected students before training and after training. Which of the following is true about the distribution of X minus Y? Okay. So are those variables independent?
No. Right?
No.
They're not independent, right? What answer did I?
You did.
So the variables are not independent, therefore, I might have marked the wrong one on this one. I'll have to go back and check. But they're not independent, right?
I thought they were independent, but I don't remember why.
Well, I would consider this a paired test, so they're not independent of each other.
I guess you're the same
Right?
person.
Same person, right? Yeah, so I might need to go back and check on that one. Yeah, because the answer should have been E.
Oh, I got it right.
Yeah.
I got it wrong.
Yeah, I should have reread that. So it should have been E for number 13.
Well, I got it wrong.
I need to go back and check.
Mark it as correct, and you cut off on that.
Say again.
If you did mark it as correct and I got it wrong,
No, I'm not gonna. I mean, you did not put E.
but you marked it as right.
Gotcha. So let's say this. So they're not independent, so the mean nor the standard deviation can be determined. Actually, it's not E, it is,
Never mind.
sorry, it's actually D,
Is it?
okay? Because, so remember this, because we just talked about this. What this is two distributions, right?
Mm-hmm.
And so what it really is the mean of X minus Y, which would be the mean of X minus the mean of Y, but what we just talked about with the paired is that would just be the same as the mean of the differences, right? So the mean is 34 seconds, right? If I take the X minus the Y, but because it is paired, I cannot use my standard deviation formula, right? I cannot do, now, I do want to remind you, and going back up in a second, we know that when we combine random variables, we can just subtract their means. But how would I find the standard deviation of the difference in their variables? So we can't do it in this one, but because they're not independent, right? It's paired data. But if I could, how would I find the standard deviation? Is that right?
Actually, I have got to. You remember the sums?
Yeah. Tell her it'll be at the end of enrichment, but yes. Okay. So how would I find the standard deviation of that difference there, if they were independent?
I gotta stop writing M when I see you.
Yes.
So Haley, you are looking at something that can be useful.
The formula sheet?
That formula sheet can help in a way, but I'm going to make it even easier. Remember, can I subtract their standard deviations?
No, just
No.
the variances.
So that's the big thing to remember is I can't add or subtract the standard deviation. It's only the variances, and spread only increases, right? And so if they were independent, that's what I would put. So did I mark D on this one?
Yeah.
That's correct? Okay, so I did do it right, yeah. So the mean is 34, but the standard deviation cannot be determined because they're not independent. Okay? So the mean can be calculated, but the standard deviation cannot.
So this formula.
So the way I'm pointing,
Because I used
Yeah.
that and I still got the right answer.
so that, I got you now.
Sorry, that's what I've been looking at.
Yeah, no. So what you're thinking about is if I'm looking at means, right? If I'm looking at the sampling distribution. And so you didn't need to divide by n.
What formula was she looking at?
She's looking at the formula sheet for on the back side of that.
Sampling distribution.
Yeah, so the sampling distributions. But notice that language of a sampling distribution. So technically it could work, but the sample size would just have to be 1. But I don't have a sampling distribution, I have a sample.
If you just subtracted them to
I
get
have no
the
clue how I got the right answer.
one sample.
What did you put for n?
402 and 368.
But I'm talking about for n.
Yeah.
Oh. Well, remember, you picked D, the standard deviation cannot be determined. That's not the correct answer. You just got the right multiple choice question or answer. But so those numbers you used were the means, not the sample sizes.
Yeah, I feel like I remember now having no clue what to put there.
Gotcha.
Something.
But do we understand why we can subtract those means, but the standard deviation, I would just have to add the variances, but I can't add the variances if they're not independent,
Yes, sir.
right? So I cannot add the standard deviations if they're not independent. And again, this formula is with sample means and for a sampling distribution. Okay? All right. So 14. Certain restaurant distribution of wait times between ordering a meal and receiving the meal has this mean and standard deviation. They want to find the probability that the mean wait time will be greater than 12 minutes for a random sample of 84 customers. Assuming the wait times among customers are independent, which of the following describes the sampling distribution of the sample mean wait time for random samples of size 84? So, let's reread that. Okay, so we want the sampling distribution, right? Will the sampling distribution be approximately normal or binomial? Be approximately normal. To be binomial, we have to have proportions, right? We don't have a proportion here. It's not following the bins. It's not binary. It is independent, but it's not a fixed number of trials. It's not the same probability every time. So it's not D or E. And what would the mean be for this sampling distribution? Remember, the mean of the sample means is the population mean, right? So 11.4 there. So we're down to A and B. But Austin, how do I find the standard deviation and B of sample means?
You have to do the standard deviation of just the sample over the square root of the population.
But do notice it would not be the standard deviation of the sample, it would be the population standard deviation.
Yeah. I had it, I just had to.
And so
think about
notice,
it.
so notice this language of the sampling distribution. So that's where we could use the formula sheet because the formula sheet has the sampling distribution, right? So then what's the correct answer?
B.
B. We good with all that? Make sense?
Yes, sir.
Okay?
At this point, I don't think I knew what bins was, even if we did learn it, so.
We're gonna learn it better, right? That's part of the review that we'll be doing. All right, in the design of a survey, which of the following best explains how to minimize response bias? So randomly selecting the sample, that reduces bias, but does it reduce response bias? Remember,
Be carefully word.
yes, right? Response bias is when we cause bias in the way someone responds. How do we cause bias in the way someone responds? By the wording of the questions, yeah. Right? Which I need to get y'all to present your projects soon. We'll have to figure out when to do that. But notice, it's not the sample size, right? Increasing and decreasing sample size does not affect bias. What does increasing and decreasing sample size do? Say it again. So variability, the spread, the variance, the standard deviation, all those words, right? Increasing the sample size decreases the spread, but if it's biased, it's biased, right? The sample size doesn't affect that. Increasing number of questions, same deal. Randomly selecting the sample reduces selection bias. Selection or under coverage. So that's what random selection does. It reduces that selection bias or undercoverage bias.
No clue.
16, we gotta pay attention to this right here. I can go ahead and tell you this regularly shows up on AP exams. Look, what do we know about this population distribution right away?
Skewed left.
It's skewed left, right? But what's my sample size for the sampling distribution?
40.
Why is 40 important?
Because it's above
It's more than 30, it's gonna satisfy the what?
central limit.
Central limit theorem. So the mean will stay the same. What's gonna happen to the standard deviation?
It's gonna increase. No.
Decrease?
Decrease, right? When we increase that sample size, the spread decreases, right? And what's gonna happen to the shape because we satisfy the central limit theorem? Becomes approximately normal. So notice how this one and this one both are centered at 85, right?
So would it be
But which one had a decrease in spread?
Oh, this one.
C?
See, I don't like that one though.
Yeah.
It's a very arduous
Yeah,
question.
it looks weird.
That depends on who's looking at it.
Well, not necessarily. So it's got to either be B or C. Let's note, right? Our standard deviation was 18 divided by the square root of 40, right? Standard deviation divided by the square root of n. What is 18 divided by the square root of 40? It's going to be square root of 36 is 6. So it's going to be about 3 for the standard deviation, right? And how many standard deviations should it go either direction?
3.
It should go roughly 3 standard deviations in each direction. Notice this goes 1 standard deviation to the right, 1 standard deviation to the left. But for this one, 85, there's 88, 91, 94. You see how it gets 3 standard deviations to the right? So the spread did decrease for both of these, but we want to always remember with a sampling distribution, if n is greater than, or if we can use the central limit theorem, it approaches normality, right? The mean of my sample means is just the population mean. Standard deviation of my sample means it's standard deviation divided by the square root of n. And you just have to remember 3 standard deviations each way. Does that make sense?
I got that one.
Okay. Were you looking at like, wait, which one? Because you had it right?
Yeah,
And you thought I was going to tell you C?
yeah, I thought you were gonna say C, and I was like, wait a
Nope,
second,
nope,
that's way more spread.
No. Well, it's actually less spread, right? Because it has bigger bars, right? But notice if the standard deviation is in fact that 3, it's actually only 1 standard deviation to the right. So that's actually way less spread than this one up here. It just has bigger bars. So be wary of that. All right, 17. Okay. An airline recorded the number of on-time arrivals for a sample of 100 flights. Box plot summarizes the data. Which of the following statements must be true? So which one? So the range. So remember, how do we calculate range?
The third quartile must.
Oh, actually, let's look again. What does this indicate? Number of on-time arrivals. So do we know what the range of the number of on-time arrivals? Oh, number of on-time. No. I guess, sorry, that is the right thing. But that's, what, 94 to 72? What would that range be? 94 minus 72, or just 22?
That got me on that one.
Yeah. IQR? Could, just based on what we just did, could this be the IQR? It says IQR of 22?
No.
No, that was the range, right? The IQR would be from here at 76 to here at 80. What's the IQR? 4. Just 4, okay. Number of days that had at least 80 on-time arrivals is greater than the number of days that had at most 76 on-time arrivals. Days that had at least 80 versus at most 76. So at most 76, at least 80. What do you know about those two sections? Austin, what percent of my data is right here?
25.
Lexi, what percent of my data is right here? Remember, every section is 25%, so this is the same number, isn't it? Same number of flights here, same number of days here. Even though this has more spread, this is the same, neither is more. So the number of days that had from 76 to 80 is equal to the number of days that had at most 76. But what percent of my data is in between the quartiles?
50.
So they're banking on you saying, hey, that's the same length or range here, but that's not what matters. 50% of my data is here, only 25% is here. So we're down to E. The difference between the median and the lower quartile for the number of on-time flights is less than 2. See how that is only 1, right? From 76 to 77. Does that make sense? Lexi, you good with that? Okay. So a small company, 40% were classified as junior level, 32% work in department A. Of those classified as junior level, 55% work in department A. So notice this right here is a what?
It is a condition.
That's a condition, right? So probability of A given junior is equal to 0.55. That's something I would notice right away. So the probability the selected employee works in department A and is not classified as junior. So probability of A and not junior. Whoa. That was just the bottom? Okay. So I'm thinking in this one, I know the probability, how would I find probability of A and junior?
Whatever.
Probability of A what?
I don't know what it is. I don't know.
But are they independent events?
Come on.
So what I would remind you is this conditional is the intersection divided by the condition. So I could find this intersection by multiplying both sections by 0.4. So remember, the conditional is the intersection divided by the condition. So if I multiply both sides of this equation by 0.4, I would get that intersection. So what's 0.55 times 0.4?
Almost know that. Almost a calculator. 0.22.
0.22?
In the same style, so much.
I like that.
And what do we know? So notice, how many work, what percent work in A?
Sorry?
So what percent work in A?
32.
32%? I guess to do this, probability of A, I think we have to do a tree diagram actually. Let me look at this one, because we only have a minute and a half left. But we have junior and not junior. We have A and not A. A and not A. And what do we want? So not junior and A. And so I multiply here and multiply here. That's the probability. Huh. Let me think on this one, because I don't remember how I did this off the top of my head. Yeah, I mean, I worked through it originally, and we only have 60 seconds. We'll have to finish this tomorrow, but I'll come back to this one.
Mr. King?
I'll work on it during 3rd block.
Is 4 o'clock your
Planning, yeah.
Could I come at 4 o'clock tomorrow to do my
Free response?
Yes.
Free test, yeah. Did I gave you your free response stuff back, right?
No, sir.
You don't have it yet?
I don't have it. I didn't come in Friday.
You ain't used the tips Mr. Minden used to give you?
Josh,
You're supposed to read the question
here,
before you read
obviously,
it.
Joseph's not here.
Do we?
I only have
That's your
Ashton's, Logan's,
It tells
Josh's,
you where to go.
and Joseph's. Check your notes again. I gave
Oh, you probably did.
I got in trouble.
I gave him, remember, did you come in after, no, I just gave it to you.
I guess the freedom.
Oh.
Freedom up here.
Is it right there? Yeah.
They ain't gonna let me
That's it.
press
Oh, that is it.
Yeah.
Okay.
Yeah. Yeah.